Nuts and bolts are made from what's called steel wire rod. After spending up to 30 hours in a furnace to soften it enough to be worked, the wire rod goes into a bath of sulfuric acid to remove any rust particles. It's rinsed in water, then coated with phosphate, a chemical compound. This prevents the steel from rusting before the bolt forming begins and lubricates the steel to make forming easier. They form the bolts by cold forging, shaping the steel at room temperature by forcing it through various dies at high pressure. The forming machine first straightens the wire rod, then cuts it into pieces slightly longer than the bolt length. The extra will become the bolt head. Each piece goes through a die that makes it perfectly round, then through a series of dies that progressively shape the head of the bolt on one end. The machine heads up to 300 bolts per minute. Here's what the heading stages look like in slow motion. This die creates a slight collar. The next one turns it into a round head. Then the last die transforms that into a hexagonal head, the most common shape. Next, the machine forms the opposite end of the bolt. A tool called the pointer shapes the bottom of each bolt, creating what's called the chamfer, the part the nut catches onto. Here's the bolt before and after the chamfer. The bolt needs threads to enable the nut to screw onto it. Once again, they use the cold forging method. High-pressure rollers press in the thread pattern, as we see here in slow motion. This is the actual speed, up to 300 bolts per minute. During each production run, they take several samples to verify dimensions. They use various measuring devices, a micrometer to check the bolt's length, calipers to measure the width of the head, and a ring gauge to check the threads. To make the nuts, they use a process called hot forging. They cut steel bars into small pieces known as slugs, then heat them to 1200 degrees Celsius to make them malleable. As we see here in slow motion, hydraulic hammers punch the slugs into hexagons, while a die pierces the hole. Then a tool called a tapper drives into the hole to cut the threads. That black liquid is a lubricant oil to minimize the wear and tear on the tappers. The nuts and bolts now go into an oven at 870 degrees Celsius for about an hour. This gives them the required strength. Then a rapid cooling in oil for 5 minutes solidifies the steel's internal structure. By now, the steel is hard but brittle, so they heat the nuts and bolts for another hour. This removes their brittleness, yet maintains their strength. The quality control team pulls samples off the line, measuring how much force it takes to break them. If a bolt meets its minimum strength requirement, it passes inspection, provided the break occurred in the threading, the weakest part. Finally, packaging, labeled among other things by size and grade.